Hi guys, today we're reviewing some factoring. So remember that factoring is when we're putting things in parentheses like this, or maybe like a number in front with them parentheses. Anytime we're breaking something down or undistributing, right? So we're doing like the box, but the other direction. So there are two options when I'm thinking about something with two terms, right? So terms here, I mean like there's one term and two terms. So if I see two terms, like this example, then I'm gonna first look to see if there's a GCF, right? So first things first, look for a GCF, right? So in this case, I can see that they both have an X in them, right? So I'm gonna go ahead and divide that X out of both of them. It's gonna leave me with X on the outside. And then if I have like two X's, X squared, I'm gonna cancel one of them. It's gonna leave me with just one X here. Plus, and then these x's, x divided by x would be 1, so we just have 8 left over. Right, so this is the same as that, it's just written in a different way. So that would be like the first format, that's GCF. Right? For this one, I see that there's no GCF because this one only has x's in it and this one only has numbers, right? But there still are two terms. So what I notice is that this is the difference, right? Difference meaning subtraction, right? And I notice that both of these are square numbers, right? So x squared would be like x and x, and 25 is like 5 times 5. So there's a fancy trick, which is called the difference of squares, which means we can put one x here and one x here, and 1 5 here and 1 5 here. And then because it's minus, we have to do one positive and one negative, because a positive 5 times a negative 5 will give you negative 25. So this is the same as this, it's just written in a different way. If you don't really quite trust me on the trick, you can always like write it back out with the box method. Say x squared, 5x, negative 5x, and negative 25. These cancel here and leave me with just that x squared minus 25. So that's why those things are equal. So these are the two methods that we're going to use if there are two terms, right? So if there's two terms, first we're going to check for GCF because that one's easiest. And then second, we're going to look to see if there's the difference of squares. Okay. If there are three terms, then we're going to think about these three ideas here. So three terms meaning like there's 1, 2, 3, right? So three terms. We're going to look at this number right here. If there is no number there, we have that invisible 1, then we're just going to use regular x factor, right? So I'm thinking of numbers that multiply to get negative 10 and add to get negative 9, right? So multiply to get negative 10, add to get negative 9. So 10 is like 2 times 5 or 10 times 1. If I'm trying to get 9, I need the ones that are close together, 10 and 1, right? So 10 and 1. And I need it to be negative 9. So I'm going to do negative 9 plus 1 would be, negative 10 plus 1 would be negative 9. So these are my numbers I'm going to use. So I'm going to break it into two pieces. I would have x minus 10, x plus 1, right? Remember, you can always check your work, but this is the same as that, just written in a different way. You can always check our work by using the box method. So x squared minus 10x plus 1x minus 10 would be x squared minus 9x minus 10, which we see is indeed that original thing there. Okay, so if there is a 1 right here, that is our x factor. That's our cue that there's an x factor. If there is another number, like for example 2, or 3 or 5 or 10 or 20, right? Any number that's in front here, right? Our a term. If our a is not 1, then we're going to first look for a GCF again, right? So in this instance, I see that there is a GCF. There's a number that I can take out of that. Think about what number that would be. What number can I safely divide out of 2, 16, and 40 and still get integers? That number is 2. So I could say, okay, I'm going to take that 2 out to the outside. And what's left over, I would have x squared. 16 divided by 2 would be 8x. And negative 40 divided by 2 would be negative 20. Right. From there, now that the 2 is on the outside, I can see that there's that imaginary 1 is there. So that means that now I can do the x factor. Right? So I'm going to do the x factor. I'm multiplying to get -20, adding to get 8. Right, so 20 would be like 1 and 20, 2 and 10, 4 and 5. Looks like 2 and 10, they're 8 away from each other. So I'm going to have 10 and 2, and you need +8. So I'm going to do subtracting 2, 10 minus 2. So I would have x plus 10 and x minus 2. I'm going to still bring down that 2 from before because we factored it out. So this is the same as that, just written in a different way. So this one is basically the same as this one over here. The only difference is that in the second one, we took a GCF out first. We took that greatest common factor out first. Okay. And then finally, I want to teach you a little bit of a trick. I don't love teaching tricks, but I think that might help in this case. So first thing I'm going to do is look for a GCF, but I notice that there's no number that I can take out of 2, -5, and 3. Right? There's nothing I can divide out with that will divide out evenly, except for 1, but 1's not going to help me. I'm not going to change it. So what I'm going to do is what I called slide and divide. So you're going to take 2 times 3, and that is going to be your multiply number. Right? So 2 times 3 is 6. And then this is still going to be your add number, so -5. So I need 2 things that multiply to get 6 and add to get -5. So I'm going to say, okay, I could do 2 and 3. I could do 1 and 6. Right? If it's positive, that means I need them to be both positive or both negative. So 1 and 6, I don't think that's going to work. I'm going to try 2 and 3, but I need them both to be negative. So -2 times -3 gives me +6. -2 plus -3 gives me -5. Okay, so I'm going to go ahead and write it as x minus 2 and x minus 3. However, this is a big however. Remember how we multiplied here, right? So everything that, like if you think, I think it's Newton, you can ask Ms. Pohl, like every action has an equal opposite reaction, right? So if I multiply, I then need to divide it back out. So I'm going to go ahead and divide this by 2, right? Because I multiplied that 2 times the 3, right? So then I'm going to simplify if I can. So in this case, I see x minus 2 divided by 2 would be 1. So we'll leave it like that. And then in this case, I can't simplify that. So the 2 is going to pop up right here. So I'm going to have 2x minus 3. This one seems a little funky, so I'm going to go ahead and just double check it with my box here. So this would be 2x squared minus 2x minus 3x and plus 3. You can see this would be 2x squared. These go together to make -5x and plus 3. And I can see that that is exactly the same as this, which means this is my correct answer. Right? I have a couple more examples, then you can check them out on Canvas if you're feeling a little crazy, but otherwise we're going to jump in. This is our big new thing. The others are, we're just practicing things we already know. Cool. Rock it out.